Welcome, my friends. In this video, I will be using the law of cosines to solve the SAS and SSS triangles. Thankfully, for the law of cosines problems, there will always only be one solution. You may recall from my previous video related to the law of sines that for the SSA case, there could either be 0, 1, or 2 solutions. We don't run into that problem with the law of cosines. We always only have one solution for these two types of triangles. Now, my advice for you is to not use both the law of cosines and the law of sines in one problem. You should just stick to one or the other. That is, if you start the problem with the law of cosines, sometimes it's possible to solve for other angles or sides using the law of sines. I would not recommend this, because in some cases you can get the incorrect answer. Okay, let me explain what the law of cosines tells us. The law of cosines says that if capital A, capital B, and capital C are the angles of a triangle, and lowercase a, lowercase b, and lowercase c are the sides opposite of the respective angles, then lowercase a squared is equal to b squared plus c squared minus 2 times lowercase b times lowercase c times the cosine of capital A. Let's think about what this means. Lowercase a is one of the sides of the triangle. A squared is equal to the other two sides squared and added together, b squared plus c squared minus 2 times those two sides again, b times c, times the cosine of the angle opposite to the side that you started with, capital A. This doesn't only apply to this side. This could apply to any of the sides. So we have two other ways we can write the formula. Let's just think about the second one. Instead of thinking about lowercase a, we could think about lowercase b. Lowercase b squared is equal to the other two sides squared and added together, lowercase a squared plus lowercase c squared minus 2 times those sides again, lowercase a and lowercase c, times cosine of the angle that is opposite to the side you started with, uppercase b. The same is true if we wanted to work with the side lowercase c. It's more helpful to memorize the idea rather than memorize the formula. The idea is if you take any side of the triangle and you square it, that is equal to the other two sides squared and added together minus 2 times those sides multiplied together times cosine of the angle opposite of the side that you started with. Notice that this formula is somewhat similar to the Pythagorean theorem. And actually, the Pythagorean theorem is a special case of the law of cosines. What I mean by that is if you had a 90-degree angle, then you would end up having cosine of a 90-degree angle. Cosine of 90 degrees is actually just 0, so that means if you had a 90-degree angle, this whole part would disappear, and you would just have a squared equals b squared plus c squared. Now, of course, we write these side lengths a little bit different if we have a right triangle, so it's always a squared plus b squared equals c squared, but in general, this formula turns into the Pythagorean theorem if you have a 90-degree angle, because this last term will just disappear. This is the formulation of the law of cosines that you should use if you are solving for a missing side. If you are solving for a missing angle, you can solve any of these three formulas for cosine of capital A, capital B, or capital C. If you solve each of these formulas for cosine, you will get either cosine of capital A is equal to b squared plus c squared minus a squared over 2bc, or equivalent formulas for cosine of capital B or cosine of capital C. If you want a way to remember these formulas, cosine of some angle is always equal to the two adjacent sides squared and added together. So if we have capital A, the two adjacent sides are b and c, so square them and add them together, and then subtract the side opposite squared, which is lowercase a squared in this case, and then divide by 2 times the product of the two adjacent sides, b times c. In general, this also works for the other two angles. If you wanted to solve for the angle using this formulation, all you would have to do is take the inverse cosine of both sides, and you would have your answer. Alright, let's take a look at a problem. In this problem, we are given two sides and the angle between them. So we have a side, angle, side triangle. The side, angle, side triangle is one of the triangles that should be solved using the law of cosines. If you have a side, angle, side triangle, you should start by solving for the opposite side. You can't solve for either of the angles because in order to solve for an angle, you would need to know the two sides that are adjacent. For both of these angles, we are missing the adjacent side of lowercase b, so we can't use the law of cosines quite yet to solve for uppercase A or uppercase C. If we want to solve for lowercase b squared, we know that that is equal to the sum of the other two sides squared, which is 59 squared plus 43 squared, minus 2 times those two side lengths, 59 times 43, times cosine of the angle that is opposite to lowercase b, which is 35 degrees. If you type all of this into your calculator, you will get that b squared is approximately equal to 1173.6225. If we take the square root of both sides, we will get that b is approximately equal to 34.258. We don't have to worry about the negative square root because we are dealing with the side lengths of a triangle, which are positive in this context. We can put the side length of 34.3 onto our triangle. At this stage, we can solve for either uppercase C or uppercase A. Note that at this stage, we could potentially solve the triangle using the law of sines. Sine of 35 degrees divided by 34.3 is equal to sine of capital A divided by 59. The problem with this approach is that you will eventually have to use the inverse sine function, which will give you an angle in the first quadrant. It's possible that the angle capital A is not in the first quadrant. It could be between 90 and 180 degrees, but the inverse sine will not tell us. If we were to instead use the law of cosines, we will only get one solution, and it will be the correct solution. So I'm going to opt to use the law of cosines. I'm going to solve for the angle capital C using the law of cosines. The formula is cosine of capital C is equal to a squared plus b squared minus c squared divided by 2 times a times b. Remember to use this formulation of the law of cosines when you are solving for an angle, and the first form when you are solving for a missing side. If we plug into the formula, we must square and add the two adjacent sides to capital C, which are 59 and 34.258, and then we must subtract the opposite side squared, which is 43 squared. Then we divide by 2 times the two sides that were adjacent to capital C, which are 59 and 34.258. If you plug this into your calculator, you get approximately 0.694. If we take the inverse cosine of both sides, we will get approximately 46.05 degrees, so we can put that onto our triangle. At this stage, we can solve for the missing angle by taking 180 and subtracting the other two angles. We will get that capital A is approximately equal to 98.95 degrees. At this point, we have solved the triangle. Let's try another problem. Here we have a side, side, side triangle, since we know 3 sides of the triangle. Our only option will be to start with using the law of cosines. As long as we have committed to using the law of cosines to solve the entire triangle, we don't have to worry about which angle we solve for first. We can choose any of the 3. Let's solve for capital C. We know that cosine of capital C is equal to the two sides adjacent to capital C squared and added together, minus the side opposite of C squared, divided by 2 times the two adjacent sides. This will become 60 squared plus 58 squared minus the opposite side of 74 squared divided by 2 times the two adjacent sides of 60 and 58. If we take the inverse cosine of both sides, we will get that C is equal to approximately 77.66 degrees if we plug this into our calculator, and our calculator is in degrees. We can place this onto our triangle. Now we need to solve for one of the other angles, using the exact same idea. Let's solve for angle capital B. Cosine of capital B is equal to the two adjacent sides squared and added together, 74 squared plus 60 squared, minus the side opposite squared, which is 58 squared, divided by 2 times the product of the two adjacent sides, 74 times 60. If we take the inverse cosine of both sides, we will get that B is approximately equal to 49.97 degrees if we plug this into our calculator. We can place 49.97 degrees onto our triangle. At this point, we don't really need to use the law of cosines to solve for the last part. We can use the idea that the interior angles of a triangle must add to 180 degrees. Capital A is equal to 180 degrees minus 49.97 degrees minus 77.66 degrees, which is approximately 52.37 degrees. We can place this angle onto our triangle. At this point, we have solved the triangle. Okay, let's solve one final problem, which is a word problem. 2 sailboats leave a port at the same time. 1 minute later, the boats are 236 meters apart. If one boat traveled 258 meters and the other traveled 295 meters, find the angle theta between their paths. So we have two boats, and we are told that they are 236 meters apart. The first boat traveled 258 meters from its starting point, which would be right here. The other boat traveled 295 meters. Altogether, this creates a triangle. We are trying to find the angle theta between their two paths. We have a side-side-side triangle and need to solve for one of the angles. We can use the law of cosines to solve for the missing angle. We know that cosine of theta is equal to the two sides that are adjacent to theta squared and added together, which are going to be 258 squared and 295 squared, minus the side opposite of theta squared, which is 236 squared, divided by 2 times the product of the adjacent sides, 258 times 295. If we plug this into our calculator, we get 97,893 divided by 152,220. This is approximately 0.643. Theta is equal to the inverse cosine of 0.643. If we plug this into our calculator, we get that theta is approximately equal to 49.98 degrees. The angle between the paths of the two boats is 49.98 degrees. Alright, my friends, that finishes this video discussing the law of cosines.